everyone, my name is Sakshi Kushwaha and welcome back to yet another video on machine learning model tutorials. So in the previous video, we made a mini project for graduate admission prediction dataset in which we predict the chances of admission, okay, on the various features. So yeah, in the previous video, we made this project with the help of a linear regression model, okay. Here, we use linear regression model. So as you already know, there are 8 steps for making any model. Like the step 1 is import the libraries, and step 2 is import the data, and step 3 is define features and target variables, and step 4 is train, test and split, and step 5 is identify the problem. As we already know, this is a regression problem because we have to predict the chances of prediction in discrete values, okay, like in the form of probabilities, and then select the model. So here we selected linear regression model, okay. And step 6 is train the model, and step 7 is predict the model. Step 8 is calculate the accuracy of the model, okay. So for calculating the accuracy, you have to firstly find the error. So there are many types of error: mean absolute error, mean absolute percentage error, mean squared error. So these are all type of error, and for calculating the accuracy, you have to just uh, if you use mean absolute percentage error, then you have to 1 minus this error into 100 because it is a percentage error, and you got the accuracy. Now we are going to discuss the same problem with the help of different model, and then finally we check and we compare the accuracy of different models. So in the second model we use K-neighbors regression model. So this is a step 5, as we know. So you have to just write from sklearn.neighbors. Like sklearn is a library, and neighbors is a module, and you have to just import the function or algorithm. Import k neighbors sorry k neighbors regression, and here you write model 2, and you write k neighbors. Okay, yeah, now your model is built, and the next step is train your model. So you have to, for training your model, you have to just use this function, fit function, and provide the x training data, train data, x train and y train, okay, and your model is trained successfully. And the next step is find the predicted value. So y predict 2, because it is a second model, so you have to just write y predict 2 and use the inbuilt function of prediction, predict model 2 dot predict, and here you write give x test, okay. And if you want to see what is the predicted value, so you have to just write, okay. So I just display the first 5 values, and if you want to see actual value, then you have to just write y test, okay. So the first value is 0.94 is the predicted value, and the actual value is 0.96, and the predicted value is here, the second value predicted value is 0.78, and the actual value is 0.74. So this, the difference between these two values is the error. So the next step is find the accuracy. For finding the accuracy, you have to just find the error. So here we use only mean absolute error, okay. So you have to just write error 2 is equal to mean absolute percentage error. Like you have to just import this line, like as it is already imported, so no need to write again this line. So you have to just write mean absolute percentage error, and here y test, the actual value, and the y predicted, okay. Y predicted, and if you want to display the error 2, So the error is 0. Yeah, this is the error, 0.094. Okay. And for calculating the accuracy, you have to just write accuracy 2 is equal to 1 minus this error 2 into 100 into 100. So the accuracy is 90.55. The second, by using this model, we got the accuracy by using K-Neighbors regression model. We got the accuracy 90.55. Okay, and yeah, and when we use linear regression model, we got the accuracy 92.172. So this accuracy is much good. So for if you use first model, then you got more accuracy. And two more algorithms are there, the third model and fourth model. We also compare these two accuracy in the next video. So till then, take care, bye bye, and give your best.